All right, welcome once again, pre-calculus students, to our next video. We're actually going to be finishing up with chapter 8 today. So we have 8.6. So we are skipping, if you're wondering, wait a second, weren't we just in 8.3? Yes, we were. We're skipping 8.4 and 8.5. They're really not necessary for just preparation for what we need to cover. So we're going right to 8.6. And the truth is 8.6 should be really easy. This is pretty straightforward stuff. So let's take a look at it. The notes will not be too much. So we're going to talk about three-dimensional coordinates. And really all three-dimensional coordinates do is we just add an extra coordinate or extra axis called the z-axis. So we deal with three coordinates, x, y, and we add the next one, z. What that looks like is it looks like this. We call these Cartesian coordinates after René Descartes. By the way, many of you might recognize the name René Descartes, famous philosopher, most famous for his saying cogito ergo sum, which, or cogito ergo sum, I guess those of you that know Latin better than me will probably correct me on my pronunciation, which if those of you that know Latin might immediately know what I'm saying. Those of you that don't, it's I think, therefore I am. But he's also did a number of things with mathematics. And so one of the things he did was a lot with the coordinate plane. And so they get the Cartesian coordinates are named after him. So our origin becomes 0, 0, and then z in the 0 axis. So see, now instead of in 2 dimensions, we have 3 dimensions. So we have our x, y plane, and then we have our z, and that describes three-dimensional space. And so all the same formulas and everything basically work just the same. We just have to add a third coordinate. So if we want to talk about distance, if you remember distance before, what we did if we wanted the distance between 2 points, between an xy coordinate, between two different xy coordinates. Now what we'll do is if we want the distance between 2 points, what we do is we simply take the difference in the x coordinates and square it, and add that to the difference in the y coordinates and square it. And now we just have to add in the z coordinates as well, and then take the square root of that entire sum. So this right here would have been 2 dimensions. Just simply add in that, and we get 3 dimensions, exactly the same as we did before. Midpoint. Okay, if you remember midpoint before, if it's in 2 dimensions, we need an x and a y coordinate that is actually in the middle between our 2 known points. So simply we took the average of the x's and the average of the y's. The average of the x's was our x coordinate. The average of our y's was our y coordinate. So when we go to 3 dimensions, we take the average of the x's for the x coordinate, the average of the y's for the y coordinate. That would be our midpoint in 2 dimensions. In 3, we simply add in the third coordinate of z. So very simple, very straightforward, just extension of what we already know. Okay, equation of a circle. So in 2 dimensions, if we have the equation of the circle, remember this is our actually special form of an ellipse. It's an ellipse where both the a and the b are the same. So when you get that a and the b are the same, it's the r there. And so that becomes our equation of the form of a circle. Well, if we're going to go to 3 dimensions, well, what's the 3-dimensional equivalent of a circle? It is a sphere. And what do we do? Well, if we start off, we're going to center it at what we call HKL. So we do have to have a third coordinate there because we're in 3 dimensions for our center. And so we see for our sphere, it looks just the same. We still have a radius. But now we have, where this would be our circle, we have a third dimension, so we have our z minus l squared for our third dimension. Once again, just a straight addition to our formula that we know from 2 dimensions. All right, vectors. One of the big things that we do in 3 dimensions is we look at vectors that describe movements in 3-dimensional space, no longer just in 2-dimensional space. So we have I, remember, is the vector in the x direction that moves 1. does not move at all in the y direction, or now when we're in 3 dimensions, or in the z direction. We have j, which still represents 1 in the y, positive y direction. So that becomes the vector 0, 1, 0. And now, because we're in 3 dimensions, we must add a vector k, which is 1 in the positive z direction, or 0, 0, 1. So those are what we call our standard unit vectors in 3 dimensions. So let's just look at how we're going to apply this to vectors. It's really simple. We're going to let u be the vector ABC, and we're going to let vector v be the vector DEF. So once again, they're in 3 dimensions, so they have an x component, a y component, and a z component. And so when we go ahead and we do operations on these vectors, if we go u plus or minus v, we simply add or subtract the corresponding components. So we have a plus or minus d. So if this is plus, this is plus. If it happens to be minus, then it's a minus. And so we add the x components together for our x component, add the y components together for our y, and add the z components together for our z. If we want to do a dot product, we do that just the same as our dot product before. Now, once again, we have a scalar when we do dot product. So we multiply the x coordinates together, multiply the y coordinates together, multiply the z coordinates together, and then take the sum of all those products. And that's our dot product. If we want the magnitude of a vector like v, well, we apply the same basic formula. We square the x component, square the y component, square the z component, take the sum of those squares, and take the square root of that sum. So just like we've been used to doing, we just simply add in a new component. So all of these are simply an extension of our existing and known formulas. We're just adding it and extending it to 3 dimensions. I expect this will be a very easy section, very easy assignment, and it should go fairly quickly. So there is your assignment. It's 9 through 16, 23 through 32, and then 39 and 40. Okay, go ahead and you can go ahead and get started on that. Once you're done, the usual, take a picture of your work, post it on the assignment for Google Classroom, and we'll have a 12:45 Zoom session for any questions and answers tomorrow. I will say, as far as the tests go, I have been making some progress on them. I hopefully will have them done this week. For those of you still having questions about, obviously I know you guys would like to see how you did. As far as testing goes for the rest of the year, what it looks like we will probably be doing is I think we'll just do one single test that'll cover chapters 8, 9, and 10. I usually test 9 and 10. They're all pretty short. 8, we only have 4 sections to 8. We're only going to have 4 or 5 sections in each of these chapters. So I think that given the difficulty of doing online testing and everything, it will be easiest just simply to have one test. So what we'll do is I won't actually do any reviewing for each individual chapter until we get through with all 3 of them, and then we'll go back and we'll do review, probably spend at least a week or more of full review of all 3 different chapters to get us ready for the test and have that done in the future. So seniors, yours might be a little bit sooner, but that'll be the plan. So if you have specific questions, you want to get more information about that, join the Zoom session tomorrow. All right. Hope things go well, and we'll see you with tomorrow in Zoom and our new video.